So like I said, they kind of get a little bit repetitive. We're just looking at different things, but the solving and all that, it still ends up being the same process. So we're at Gay-Lussac's law. The volumes being constant, so that means it's not part of the equation. Then the temperature increases, the pressure will also increase. You may have just seen this last week when we had all of our snow. You may have gotten in your vehicle and your tire pressure may have come up low, even though maybe the week before it was fine, and that was because the temperature decreased, so the particles in your tire, the gas particles were moving around less. So, and hitting the sides of the tire, so that decreased the pressure. This is a direct, or they are directly related. If a gas is in a fixed container, as the temperature increases, the molecules collide more frequently with the walls of the container, and this is going to cause an increase in pressure. Formula is P1 T2. Just like we said before, temperatures not ever always seems to be on the wrong side. So in other words, the variables that it are with is the opposite. I had trouble saying all that. P2 T1. Then still temperature has to be in Kelvin. Pressure has to be in the same units if it's not. So this one says, what is the pressure inside a 0.250 liter can of deodorant that starts at 2.5 liters and 1.2 atmospheres? So that's my V1 and my P1. If the temperature is raised to 100 degrees Celsius. Oh, wait, I think this one left. This is where there's a typo on this one. Hold on. This needs to be, we need a temperature. This needs to be 50 degrees Celsius. Now, that makes more sense. So that's my T1. And then this would be my T2. So this ends up being 373 K. And this one ends up being 323 K. Just added 273 to both of those. So my formula is P1 T2 is equal to P2 T1. And I am solving for my P2. So if I rearrange that, I get P2 is equal to P1 T2 divided by T1. Or you could just plug your numbers in if you prefer to do it that way. So P2 is equal to, my first pressure was 1.2 atm. My second temperature was 373 K. And divide that by my original temperature, which was 323 K. Just take your top and divide it by your bottom. 1.2 times 373 divided by 323. And this 1.2 atmosphere, that's going to control my sig figs. It has the least number, so that means my answer can only have 2 sig figs. Kelvin canceled out. The units I'm left with is atmospheres, which makes sense because I'm trying to find a pressure. So I got 1.4 atm. So like I said, pretty similar to what we were doing yesterday. No, I used it correctly down here. It's supposed to be 323. All right, why don't y'all give the next one a try real quick? So you're using some information from the problem in front of you, so the original information from that. So your P1 and your T1 would come from that problem we just worked. Let's see what you get for that one. Okay. You got what? 203. Let me work through it because I didn't get that. So I'm gonna, on this one, I'm just gonna work instead of rearranging, just plugging in the numbers. So my formula is P1, T2 is equal to P2, T1. So my pressure one came from my problem up above. My T2 is what I'm trying to find. My P2 is here. And my T1 would have also come from my one up above. So that was that 323K. So I need to solve for T2. So that means I have to divide each side by 1.2. That cancels. And this is what I would put in my calculator. 2.2 times 323. And get me an answer and come back and divide by 1.2. My atmospheres cancel out. So I got 590K. Did anybody else get that? Ethan, did you see what you did wrong? Sometimes people switch those temperatures because you kind of want to put temperature one with P1, but their temperatures are always going to be on your opposite side. Yes, ma'am. Is your setup just like this? So 2.2 times 323?
Oh, I put 7.
Okay, that's no problem. I do that kind of stuff all the time. All right, then the last one we're going to look at today is your combined gas law. And by the way, if you, that one was called Gay-Lussac. It's not on your peak sheet, but if you want to add it to the bottom of your peak sheet, you're welcome to do that. So you'll have that formula. The other one that we're looking at is the combined. It's also not on here. You'll have to add it to the bottom. So the combined just looks at all three variables that we are looking at, have looked at so far at the same time. So it's a combination of the previous gas laws and the assumption that the number of molecules stays the same. So that would be related to the number of moles, which is going to be our little n. We haven't done that one yet. So my formula is P1 V1 T2 is equal to P2 V2 T1. Temp in Kelvin. Units the same. So if you want to take a second and put that formula down on the bottom of your peak sheet, this might be a good time to do that. So the only difference between this one is that whenever we solve, we're going to be dividing by two things instead of just one. All right, so it says we have a 15-liter cylinder at 4.8 atmospheres pressure and 25 degrees Celsius. So that's all my starting. So V1, P1, and T1. And when I add 25 degrees to 273, I get 298K. And then it's compressed to 75 degrees Celsius. So that's going to be my T2. And 17 atmospheres, so that's my P2. So what is the new volume? I'm trying to find V2. So let me go ahead and get my temperature change. 75 plus 273 is 348K. If I look at my formula, P1, V1, T2, P2, V2, T1. What is my unknown? My unknown is V2. So that means when I rearrange, I need to take P2 and T1 to the other side, and they'll be now as denominators. They'll be on the bottom. So that means it would be V2 is equal to, probably have to get, oh, you okay? Get rid of that real quick. So V2 is equal to P1, V1, T2 over P2, V2, not V2. How about T1? Is that better? All right, a lot of variables, but we got them all. We just plug them in. So now it's just a plug and chug. Pressure 1 was my 4.8 ATM. Volume 1 was 15 liters. So that means when I solve for my volume, it's going to be in liters. Temperature 2 was my higher temperature, 348 K. And divide all that by pressure 2, which was 17 ATM. And I noticed as I was reading that they're both in ATM. If one would have been in something different, I would have had to convert them to the same units. And my temperature 1 was my 298 K. And for sig figs, it doesn't matter this particular one because that 17 and that 4.8 and 15 keep me for 2. But for sig figs, you always look at your sig figs of your temperature after you change it to Kelvin. All right, now just putting all those in my calculator. Divided by 17 times 298, and we said just 2 sig figs. So I got 4.9 ATM. Anybody else get 4.9 ATM? Because y'all are my first class. I've done these numbers, y'all are my checkers. So, I mean, a little bit more work on that one. Anybody have any questions where any of those numbers came from, or did you get a different number? Or if you're going to divide, yes, you're going to have to put that in parentheses. It's not a, I don't really understand it, but the calculator does another order or something if you don't put them in parentheses at the bottom. Is it a what? Oh, sorry. How about? Thank you. It's only my first period. Okay, so that question, I'm sorry, I didn't understand what you were saying. Okay, then did y'all get 4.9? Okay, and I think maybe you just have a number in there wrong or something. Why don't y'all go ahead and try the next one? Did you see what it was? Okay. I'm gonna, just like yesterday, I'm gonna give you some answers on the other page for the practice, but don't write down this number you can see. I'm gonna have you change the problem up a little bit. All right, Aaron, what did you get for that one? 5, but I think we could only have how many sig figs? 2, so it would become 590. Oh, I thought you said 592. Okay. Get my hearing checked. Huh? Okay. Probably the K, it sounded like a 2. That's okay. So this is a setup if you want to, if you didn't get 590 or 592. If you didn't get 590K, then this is the setup for that. Same thing we've been doing, just more numbers to have to deal with. All right, so you have a packet of practice, and then I also have some practice problems in the notes like we did yesterday, but I need to make some changes. This first one, this is sig fig wise, it gives you a really ugly sig fig that has to be written in scientific notation, and that's a pain. So let's just change this up a little bit and change that 3.5 to 4.50. And then you'll get a prettier number. And 781K. The next one is good. And it looks like it's for this problem, but this one, the 6.13 is for the second problem. The 1.44 is for the next one. And then 95.6 is good, but then I'm going to come down here and change this a little bit. It should just be sig fig wise, you should just end up with, if you change it to Celsius, you should just end up with 36, no places behind the decimal. The very last problem. What is it? Which one, babe? From the very top. 95.6 kilopascals. All right, give one a try. I think you have time to give one a try before we pack up and call it a day and a week. You will have a quiz on Monday over Charles and Boyle's law, which is the one we did yesterday. And those tutorials on the board are mine for next week. I did a lot on Monday and Tuesday and Wednesday morning because those are all before the stoichiometry free test. Cheyenne, you maybe want to try before we pack up then. Yes, ma'am. Let me look. On the one of the practice in the notes or the practice? I got 781K. You got 7.81. Let's double check. I got, you want to look at my work? I got, you get something you want to? Okay. Alrighty, once you get yourself one done, then pack it up. I have a quiz over this one on Tuesday. And that'll be on paper. Show his work. I know this is a one where some of my students will be doing show your work. Show your work.